Welcome to second steel making course. Today I am going to talk about stream gassing methods. There are types of stream gassing methods. One among those is ladle to ladle degassing methods, such as this is one ladle and this is one ladle and this is another ladle. Ladle to ladle degassing methods. There is another method called tap degassing methods. As you are tapping from electric arc furnace, that particular molten steel will be poured in a vessel which is nothing but tundish or pony ladle, and from that particular tapping, as you are tapping from the furnace, you will be processing and homogenizing the composition, temperature controlled, saving the temperature. All those things will be done at tap degassing methods. In case of ladle to ladle degassing methods, there is a provision that you can add while it is being tapping from one ladle to another ladle while the molten metal is pouring. This particular rod is stopper for this particular bottom plug. It is been connected with crank hook, just like this particular situation, and whenever you want to start, you will just move it up and it starts flowing. There will be passage, stream director is being provided, and there will be another provision of addition of allying elements. For example, if you want to add ferrochrome, so you can add ferrochrome and you can convert that particular steel into stainless steel at this particular stage with this kind of methods also. And if you want to control carbon to be lower and to reduce the carbon, can be provided vacuum sealing for this particular ladle, and exit CO gas can be passed through exhaust. There are n number of provisions. These particular principles are followed in a next one of the example process. I will be taking steam degassing, and where ladle to ladle degassing, tap degassing, kind of these principles are in practice. This particular thing is no vacuum provision was given in the case of tap degassing methods while it has been tapping. If it is separated, so there will be a vacuum sealing is provided for entire bottom ladle. So you can do decarburation, you can do allying additions, you can convert the steel to stainless steel, one of the example. There are many provisions are there with this kind of principles. And in the last class we were talking about only VOD process, AOD process. Those are the ladle degassing process, only single ladle degassing process. There are RH and DH degassing process, which are circular motion circulated degassing methods, or RH and DH degassing methods. Please make a note at this stage. Today I am going to take one of the example where superheated steam is used to make stainless steel. This particular process is called CLU process. CLU stands for creosote, luer and Udelm. There is a place in Sweden called Udelm Degors. That particular place, steel plant, developed initially this kind of ladle to ladle degassing process, and later it is being developed by France, and based on those cities, creosote and luer, it is renamed with CLU process. It is initially it is been started here and further modified by these things. It was happened in and around 1970. First it was in the Sweden, Europe countries, and moved to this France, and later it was in practice with CLU process. Even in a modern days, it is under practice with using a principle called ladle to ladle degassing, and where superheated stream is being used. From the bottom, mixture of oxygen, steam, argon, nitrogen, air is being blown from the bottom, so that you will be having the many advantages. This particular process is not different from AOD process. In the case of AOD process, it is argon oxygen decarboration. There was a decarboration is occurring, there was a sulfur reduced and chromium recovery, and there was oxidation happening. These are the things which were happening in AOD process. This was the step after electric arc furnace melt is prepared. It will be taken into the AOD process. It is made stainless steel with that particular duplexing stainless steel route. But this particular CLU process also very much similar to AOD process. The only difference is the liquid steel from electric arc furnace is taken. That was the primary step. After that, this particular superheated stream will act as a diluting gas, just like in the case of AOD process it had argon, whereas in the case of CLU process H2, hydrogen will act as this particular stream. Further, once it is injected into the molten steel, it dissociate into the hydrogen and oxygen, both different molecules, and those particular hydrogen will act as further processing parameter, and these are the things which can be used mainly to homogenize the chemistry of molten metal. And this particular steam, by the process of superheat steam, you can control the temperature before going to the continuous casting process. Temperature is under maintained, and chromium which was oxidized in the EAF process will be reduced or recovered back by the addition of ferrosilicon or chromium silicon additions. This is also one of the important point one need to remember. Basically, the steam is nothing but H2O. It is endothermic reaction. For making water to steam, you consume the energy of 241 kilojoule per mole, and further this particular steam is injected into the liquid steel. It dissociate into hydrogen and oxygen. The hydrogen will act as the flushing gas, just like in the AOD process argon, and O2 will act as a refining medium. It will refine the silicon, manganese, iron and calcium, sulfur, all those things. It refines. It will reduce the impurity. This will remove the impurities in the form of various slag compounds. This particular process of doing steam bath, it controls the temperature, and other than that there are many advantages. As I mentioned, it is the endothermic process, and there is a possibility of temperature control during the decarbonation itself. While you poured in the ladle to ladle degassing type, this stopper is, this is the bottom plug. It can be stopped and it can be opened. It will be moved with the crane top so that it will be opened, and the molten metal will be passed to the continuous casting section. And that particular process where decarbonation will also occur, but temperature is under control because of superheated stream was used in this situation. And the cost of using this particular converting the water into the steam is comparatively low when you compare with the argon gas, and that this can also use low priced or low grade ferrochrome can be used, or ferrosilicon, or with the carbon additions can be used for allying addition to convert the steel to stainless steel. And the temperature is also very low when you compare with the AOD process. It is around 1680 temperature. The history of this particular process I mentioned with the concluding remarks that this particular process is used to make stainless steel, which was developed in early 1970s in Udelm Degerfors steel plant in Sweden, and this France has adapted this process and developed in this particular group of cities, and further it is named as a Creusot Lior Udelm process. In shortcut it is called CLU process. In nutshell it is called CLU process. There are one advantages. This process uses the steam degassing, ladle to ladle steam gassing. There was vacuum provision also, as I have shown this particular process. This uses CLU process uses this principle. Please make a note. Now let me conclude with one of the important point for you is that what is the uniqueness of CLU steam gassing process when you compare with AOD process? Is that only super stream or not? Please give your opinion as true or false. Thank you.